Welcome to another lecture on the topic of reciprocal of a linear function. In this investigation, we are considering a reciprocal function y equals 1 over kx minus c. As you see, the denominator is a linear function, and 1 over that linear function makes this function to be a reciprocal function, or generally speaking, a rational function, a particular type of rational function. The restriction on the domain of this reciprocal linear function can be determined by finding the value of x that makes the denominator equal to 0. So the denominator is kx minus c, and k and c are just real numbers. So x equals c over k, I have shown it here, x equals c over k, would be the equation of the vertical asymptote, which is that vertical line that graph approaches from right side and left side, but never touches it. The vertical asymptote of a reciprocal linear function has an equation of the form x equals c over k, as I mentioned earlier. Now, the horizontal asymptote of a reciprocal linear function has the equation of y equals 0. Y equals 0 is this green line that you see, and it represents the x-axis actually. Now here, the value of k is positive 1 and c is 0. So basically, this equation becomes 1 over x, which shows the basic parent function for the reciprocal function. That is 1 over x. So y equals 1 over x has a graph that is exactly as you see on the screen. So this point here, for example, has coordinates of 1 and 1. If I can show it to you, it's 1 and 1. Or this point is like negative 1 and negative 1. So the graph of 1 over x is clearly shown here. But then if we change the values of k and c, we are going to see what is going to happen. So I'm going to change the value of c to, let's say, 1, and we saw what happened. So the graph started horizontally shifting to the right. So there you go. So this is the graph of 1 over x minus 1, basically. And this would be 1 over x minus 2. As you see, the vertical asymptote right now is x equals 2. But right now it is x equals 1. Okay, it's x equals 1. Now the value of k is positive. It's positive 1. I can change it to other positive values. For example, it can become 2.5, 3, 4, 5. And as you see, the graph is horizontally basically shrinking or horizontally compressed by a factor of 4.5 in this case, for example. So that's the role of k. It transforms the graph of the function in a way that it horizontally shrinks or compresses the graph by a factor of, basically we can say by a factor of 1 over k, by a factor of 1 over k. So if this is like 4.5, it's going to be 1 over 4.5 by a factor of 1 over 4, because the x coordinates of the points on the graph are being divided by 4.5. So that's why we say by a factor of 1 over 4.5. Anyhow, that's the effect of k. You see, if k increases, so the graph starts horizontally shrinking more and more by a bigger factor. And if this factor is smaller, then it doesn't shrink that much. Okay. So if k is positive, the left branch of this reciprocal function has a negative decreasing slope, and the right branch has a negative increasing slope. So what does that mean? If I just show it with this situation, so you see all these points on this left branch of the reciprocal linear function. All the tangent lines that you draw at these points, all of those tangent lines would be lines falling from left to right having a negative slope. So the slope is negative for sure. And even on this branch, at these points, if you draw tangent lines, all those lines would be, again, falling from left to right, having a negative slope. So slope is negative, there's no doubt about it. But for this left branch, it's a decreasing slope as we move from left to right. But for this right side branch, it is an increasing slope as we move from left to right. Now, all these things I said is valid if k is, of course, positive, like 1 or like 2.5 or any positive number, 4 or 6.5 or whatever. Okay. Now, what happens if k is becoming negative? Let's investigate, first of all, what happens if k is 0. Okay. Right now, k is positive, but what happens if k is 0? If k is 0, we end up with 1 over negative c. That's a constant. That's a constant. And if c is 1, we end up with just negative 1. So I'm going to make this k to be 0. Okay, so right now, you see a horizontal line. And if k is 0, we end up with 1 over negative c. That is 1 over negative 1. That is negative 1. So y equals negative 1 is what we end up with for that particular exceptional case when k is equal to 0. And y equals 1 is just this horizontal line, as you see. So we don't even have a reciprocal function, or we don't even have a rational function. That's a very, very special case. Now, if k was positive, we investigated. Now, what happens if k is negative? So if k is negative, we see that the shape of the graph changes a little bit. So if k is less than 0 or negative, the left branch of this reciprocal function has a positive increasing slope. See, if you draw different tangent lines on this left side branch, all of these tangent lines are rising from left to right, having a positive slope. So that's why we say that the slope is positive, but at the same time, it's increasing from left to right. And the right branch here, has positive again, positive slope, but decreasing slope. Now, from left to right, if you draw different tangent lines, you're going to see that the slopes of those tangent lines are decreasing from left to right, although all of them are positive. So now I want to change these two factors, and we see what happens to this rational function when the values of k and c just change randomly. You see what happens. So I'm going to keep c value to be like, let's say 2 or like 3, okay? And we change the value of k and see what happens. So right now, left side branch is above the x-axis, but now left side branch is below the x-axis. So here the right side branch is below the x-axis for negative values of k, but right now you see the right side branch for positive values of k is above the x-axis. So that's the change that is happening. So here is like the left side branch is above the x-axis, and here the left side branch is below the x-axis. So that's the effect of changing value of k such that sometimes it's positive, sometimes it's negative. All right. So horizontal asymptote always y equals 0, and the vertical asymptote x equals c over k, whatever the numbers are. Okay. Thank you, and we'll talk later.